Okay, so let's take a look at the line y equals x plus 4. This should be very familiar. Grade 10, y equals mx plus b, a line. And let's write down what's called the reciprocal line. Print out the notes, highlight the notes. Y equals 1 over the line. So the first thing that we want to do is we want to find what's called a vertical asymptote. And I'm going to say VA colon. And the method is exactly the method that we just did in the last section for reciprocal restrictions that I reminded you that we've done from the last section or a couple sections, rationals. The denominator can't equal 0. We can't divide by 0. This has been the same for 5 years. Grade 8, grade 9, grade 10, and grade 11, we can't divide by 0. So the denominator can't equal 0, obviously. Now this is a vertical asymptote, so we want to know whether it's equal to 0. So as I expressed last time, sometimes it's equal to, sometimes it can't equal to. But the vertical asymptote is equal to. So we're going to set the denominator equal to 0. From above, the denominator, the bottom, minus 4 from both sides, x equals negative 4. Circle your answer. That is the vertical asymptote. X equals negative 4. Now what is that? Well, I'm going to draw the graph down below. And not as big. X and Y, whatever. So the vertical asymptote that we just figured out, x equals negative 4. Well, that's a vertical dotted line at x equals negative 4. 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So we put a vertical line exactly where the vertical asymptote is. What we should have done immediately, my apologies, but all good. Let's just put an arrow from it to the step. We're going to graph the original. So the original is just y equals x plus 4. Again, you can graph it with a table of values like I painfully did to you earlier in this section or earlier in this chapter. But I'm just going to graph it with y equals mx plus b. So we have a y-intercept of 4 and a slope of up 1 over 1. Whoa, look at that. The location of where the original's x-intercept was the location of the vertical asymptote. Obviously, because where the original equals 0, the reciprocal does not exist. We cannot divide by 0. So, as you can see in the notes, I've done a bunch of points. And you will learn the most in math by carefully doing tables of values near things, rather than the lazy hack method I'm going to show you right now. Again, make a table of values on your own. Pick the x values, whatever. Figure out the y values are, draw the graph. But, again, I'm going to teach you a little quick method. So, this is not exactly on the notes. So, let's take the equation above, x plus 4 in our head. So, when that graph has a y value, I'm just going to circle it. A y value of 1, excuse me. When that graph has a y value of 1, I'm going to circle it. Because when this one, the one at the top, has a y value of 1, again, down on the graph in red, a y value of 1, well, then this one will also have a y value of 1. So this red point here is called an invariant point. It's a point that does not change. And the way we're going to graph these things is, in English, close to the vertical asymptote, through the point close to the x-axis. Again, do a table of values. Put it in your graphing calculator. Make sure it all works. Now, again, above in big blue, when the first thing is -1, the second thing is also -1. When the first thing is -1, the second thing is also -1. Because 1 over 1 is 1, and 1 over -1 is -1. So when our original line is -1, the y value, again, we have an invariant point. And we're going to graph it by close to the vertical asymptote through the point close to the x-axis. Keep in mind, this is a very elementary way of graphing this. So I threw in some extra English instructions. Some of those ones I was actually reading, they're in places that I couldn't exactly find on the page at the time that I got to them, but they are there. So in order to graph these things, we have draw the original. Find the vertical asymptote. Find the location on the original where y was 1 and -1. And then draw funny looking LCs. So, as I mentioned before, anytime we learned a new graph, I would go over all the graphs that we've learned until this point. So, we've seen the line from grade 10, and we've moved it around and shifted it. We've seen the quadratic, the parabola, and we've moved it around and shifted it and upside down, and we might have talked about the cubic. We saw the absolute value, the V, and the W. And now we just saw reciprocals, the funny looking LCs. And they might not always be in this quadrant. They might be up here. We might have multiple vertical asymptotes. And that's what we're going to see next. So this is a linear. And now obviously we're going to do a quadratic.